I'm going with RH criteria. I'm going with RH criteria. In RH criteria, we know how to make the table, characteristic equation. Okay. So what all you will study? First, I will last 15 minutes I will tell you all the headings in short. Okay. What main things, and here in the entire discussion formulas everything I will put in single ppt. Okay. So now I am starting with RH criteria. RH criteria, we have the characteristic equation. So a naught s power n, a1 s power n minus 1, a2 s power n minus 2, and so on. Okay. A1 s plus this is a n minus 1 s a n equal to 0. This is called characteristic equation. The necessary and sufficient condition is all the coefficients should be positive and no missing coefficient should be there. That is necessary condition only. Based on that we cannot decide it is stable unstable. That is necessary condition only. Next we have to go with the table, RH table. RH table means we have to make all the odd terms in the first line, even terms in the second line. So s power n terms, s power n minus 1, s power n minus 2, like that we have to complete up to s power 0 row. Up to s power 0 row. For first two rows we will fill with the given equation. First two rows elements we will fill with the given equation. Then we have to calculate in this pattern. Okay. So first row we will take this as a0, a1, a2, like that. Second row we will take b0, b1, b2, like that. In the next row calculation is b0 a1 minus b1 a0 divided by b0 should come. Okay. This is first element calculation. Next element calculation we have to go like this: b0 a2 minus b2 a0 divided by b0, that will come here. Okay. Like that alternatively we have to calculate. Then coming to the s power n minus 3 row, previous two rows we have to use in the calculation. Like this we have to complete the RH table. Then we have to check in the first column of RH table number of sign changes. That number of sign changes equal to number of roots on RHS. Number of roots on RHS. If at least one root on RHS, system is unstable. Okay. At least one root on RHS, then we will say system is unstable. If roots are present on imaginary axis, okay, roots are present on imaginary axis, we will say system is marginally stable. Then if there are repeated roots on imaginary axis, again unstable. Repeated roots on imaginary axis, okay, then also it will be unstable. If all the roots are on LHS only, all roots on LHS only, in this case we will say system is stable. Okay. So these are the conditions. Based on number of sign changes we can decide how many roots are coming on RHS. Okay. Then what about imaginary axis? How many roots present? If there is any complete row of zeros, then definitely it will give possibility for the roots on imaginary axis. In the RH table, okay, if complete one row of zeros are there, how to proceed? We will take the previous row as auxiliary equation, differentiate that with respect to s. Then after differentiating, whatever values we get, you fill in the place of zeros. Differentiate. Okay. And after differentiate, take those coefficients as substitute for in the place of zeros. Okay. Zeros in the row of 0. In the place of zeros, replace the zeros, okay, in the complete row of zeros. Then proceed and complete RH table. Then once RH table is completed, what is our general procedure? How many number of sign changes in the first column of RH table? How many number of sign changes are there? Based on sign changes, again we will tell RHS how many roots are present. But in between we got one row of zeros. No, definitely there will be possibility of roots on imaginary axis. How to find the roots on imaginary axis? You have to find the roots of auxiliary equation. Okay. So you find the roots of auxiliary equation, and those roots are present on imaginary axis. We have to find roots from the auxiliary equation, roots of auxiliary equation. Those roots are on imaginary axis. Okay, so here we have possibility these roots may be plus j omega minus j omega, then we can say marginally stable. Okay, but if there are repeated roots, this is called marginally stable. But if there are repeated roots, which means, just 1 minute. If there are repeated roots on imaginary axis, repeated roots on imaginary axis like plus 2j plus 2j minus 2j. Okay, roots will be complex conjugates, no? Minus 2j, two times it is coming. When you do the pole zero diagram, do the pole zero diagram, if only one set of roots plus 2j and minus 2j are there, it is marginally stable system. Okay, but if there are repeated roots plus 2j two times, plus minus 2j minus 2j two times, this is called repeated roots on imaginary axis. In this case we will decide system is unstable. Okay, so if we have no roots on on RHS, no roots on RHS, but only roots on imaginary axis, we will conclude it as marginally stable. But if at least one root comes on RHS, that is the utmost priority. Okay, with imaginary roots, at least one root on RHS, we cannot conclude marginally stable, but we have to say it is unstable system. Okay, so these are the different things you have to remember in RH criteria. In RH criteria, RH criteria, in the RH table. Okay, so three different cases are possible. First case is first column sign changes. First column sign changes after completing the table. Second thing, first column only first element, one of the row. Okay, in one row first element is 0. First element is 0. If it is 0, in the calculation denominator will come 0, we cannot do anything. So assume that 0 as a small constant epsilon. Okay, then complete RH table. Once RH table ending come, then replace all epsilon with zeros back. Replace all epsilon with zeros back. Okay, then decide how many sign changes in the first column. Okay, after this number of sign changes in first column you have to check. Okay, in first column you have to check. This is the second model in RH table. Third model, what is that? Complete row of zeros will come. Then previous row we have to take auxiliary equation, differentiate that coefficients, put in the place of 0, do the complete calculations, come to the end of the RH table, then find the roots of auxiliary equation, those are imaginary roots, and number of sign changes are there, those are roots on RHS. And total number of roots means, in the characteristic equation highest power of s is nothing but total roots. Then how you will decide number of roots on LHS? Total roots minus number of roots on imaginary axis, number of roots on RHS. When you subtract, roots on LHS will come. Okay, so roots on LHS is the last priority, but at least one root on RHS immediately conclude unstable. On imaginary axis repeated roots are coming, conclude unstable. If no RHS roots, no repeated roots on imaginary axis, but there are one set of roots on imaginary axis, conclude, then only marginally stable. All these cases are not there, all the roots are on LHS, in that one case only we can say system is stable system. Okay, this is about RH table overall revision. Now problems we have seen in the regular class, I cannot tell particularly which problem will come, but there is possibility of problems. Okay, there is possibility of problems. Yeah, they may give you the characteristic equation s power 4, 3 times s square, 2 times s plus capital A equal to 0. Find a value. Okay, find a value for system to be stable. System to be stable. Complete the RH table. Number of sign changes in first column is number of roots on RHS. When you operate that, a value will come. A value will, all the, because it is said stable, what you have to do, because it is already said stable, all the first column no sign changes, so all the first column elements make it positive. Okay, because previous elements positive means continuous positive, previous elements negative means continuous negative. So first column elements all are positive, greater than 0. When a is there, 5k, 2k, 2a, 3a, something is there, or 2a plus 3, 5a plus 3, something is there in the first column element, make it greater than 0, there you will get a value. Okay, so something like that you have to operate and calculate the a value. This is about the first possibility of problems. Second possibility, they may give you the roots. Okay, so pole 1 minus 2 plus 3j, pole 2 minus 5, complex conjugate should be there, no? So pole 2 minus 2 minus 3j. Next, the third pole minus 4, 5. Fourth pole, it is plus 2. Then fifth pole, okay, fifth pole, it will plus 2j. Next, sixth pole minus 2j. Now say stability of the system. Comment on system stability. Okay, comment on system stability. Here in this set of poles, you have at least one pole on RHS, so you have to conclude system is unstable. Okay, answer system unstable. If this is not there, all poles on LHS only, you have to say system marginally stable. And no RHS poles, but imaginary poles are there, marginally stable, you will say. Okay, all poles LHS means you have to say system stable. Okay, repeated poles are there, then you have to say it is unstable system. On imaginary axis, repeated poles. Okay, this is a second possibility of question. Third possibility, you find the roots on imaginary axis. Okay, you find the roots on imaginary axis, something they may give. Then auxiliary equation you have to find, RH table after completion, RH auxiliary equation, roots of auxiliary equation. Okay, so if I roughly give some question, 0 row should come, no? 0, I cannot by heart question like that. If characteristic equation is given, okay, characteristic equation given, one row is becoming, so that one row will become 0. One row is row of zeros. They may ask you find the imaginary roots. Okay, find roots on imaginary axis. There you should be able to do auxiliary equation. Okay, the previous row to row of zeros, find the roots of auxiliary equation, that become roots on imaginary axis. Okay, so this is about RH table. I think all possible questions I have done it. RH table, all possible questions.